Good afternoon, everybody. I'm glad to see that you all are here, and I'm glad to see that most of you are participating in our last day of Spirit Week, Hat Day, as you can tell. I love to see your participation. I definitely appreciate it, guys. Good job on participating in this Spirit Week. I hope you've had a great week. I know I have. We've got our big crosstown rival football game tonight, so if you're not a band member, cheerleader, or football player, I highly encourage you guys to come out. Our student tickets are $5 off tonight. We like to encourage all of you guys to come out and fill our student section up, hang out with your friends, get some good food from the concession stand, and bring the energy for the crowd just to lead our team to a big win tonight. Super stoked for that. But with that being said, I'm sure that you guys are going to be super upset that I'm going to have to inform you that our math class period today is going to get cut short because of the pep rally for this game tonight. Don't show your emotions too much. It's okay. I'm pretty sad about it too. It's okay. I'm just going to keep building off. I'm going to keep our lesson really short today and build off of what we've been learning all week. The biggest thing we've learned this week in our new unit is that the properties of the right triangles. The biggest one being that our sides of our right triangles are directly proportionate to our angles. So for example, I've got us a right triangle up here. Obviously this is our 90-degree angle. For this example, I'm just going to put this angle as 30 degrees. Now, as we know, all interior angles of a triangle must equal how many? 180 degrees, guys. We learned this however long ago. You guys should know this, and you should probably figure out what this angle is already. You probably already know. It's 60 degrees. And like I said, like we've been hitting on all week, our sides of the right triangle are directly proportionate to the angles. So as you can tell, 30, 60, and 90 degrees are all directly proportionate to each other. They have one number in common. With that being said, you can determine the sides of the right triangle based upon these angles. For example, 30, we can just indicate that this side directly across from the 30 is 1 unit. Well, 60 is double 1, so we can just assume that this is a 2-unit side. Now, we could go through and use our Pythagorean theorem and figure out what our hypotenuse is of the right triangle, but I'm going to teach you a little, we've been hitting on all week, that our angles are directly proportionate to our sides. So, if 30 is for 1 and 60 is for 2, 90 must be for 3. Now, I know you guys already know that, so I just wanted to refresh your mind on that. Today I will be introducing a new topic. And I don't want this topic to scare you guys any at all because it's not that complicated and it sounds scary, but it's not. The new topic is called trigonometry. And some of you all may have heard that. Does anybody know anything about trig? Okay, well, that's good. I've got more to teach you guys. Trigonometry is basically building off of what we already learned, the angles and the sides of the triangle. But you can figure out individual side lengths or individual angles of the triangle based on given aspects of the triangle, such as other sides or other angles. For example, got us another 90-degree right triangle, and we are wanting to find the measure of this angle given this side is 2. Now, most of you probably don't know how to do this, but that's okay. We'll come back to this in a second, but for right now, on a clean piece of notebook paper, or just continuing off of your notes that you've been taking all week, I want you guys to write the term SOHCAHTOA. And I don't know if that's in your vocabulary already. I'm sure it's not because it's not a real English word. It's an acronym. So I'll teach you how to spell it. It is SOHCAH-TOA. Now this you will want to embed in your memory because you will use this over and over and over again. So I highly suggest on your notebook paper, I highly suggest writing it across the biggest part of your paper and just leave it there for reference. So you may be curious as to what these mean. Why is it divided into 3 different parts? So our first term of SOHCAHTOA is SO, S-O-H. And trig is composed of three main aspects. It's sine, cosine, and tangent. So obviously, I'm sure you can guess what this first letter means, is sine. So back to our problem, if we're wanting to figure out what this angle is, now this may scare you as well, I hope it doesn't. It is called theta. Now theta is just a Greek letter. I don't want it to scare you guys because we use letters all the time in math, solving for x, for example. We have that all the time. So don't think of this as some crazy letter. It's just a letter of a different language, and then what we're going to use to indicate the angles. So sine of theta, the angle that we're trying to find, is equal to OH. Now what does OH mean? OH means the opposite. And the offset is the side. We're talking about sides and angles. So it's the opposite side length divided by the hypotenuse, which would be this. Now, C-A-H would be for cosine of theta. And I'm sure based on what we've already learned from sine, cosine is equal to the adjacent side divided by the hypotenuse. And the adjacent side to the angle, so for example, theta in this case, this side is obviously our hypotenuse. The adjacent is just the other side. Now if this triangle were based upon this angle, our adjacent would be this number 2 here. But moving on from that, our tangent of theta is equal to OA, which is opposite side divided by adjacent side. Now I'm going to give you some time to write these things down in your notes because I know this can be confusing, but you will need to know these. I will not be giving you these for our tests. I expect using this acronym, if it's ingrained in your memory, you will have no problem remembering that, so don't freak out about that, and we'll hit on it numerous times, so there's nothing to stress over. Now using these, we can simply solve for whatever side or whatever angle we want. Now for example, we'll go back to this example. Now what do we have? We are looking for, and I'll give you this. We're looking for the angle of theta. This is the angle that I've determined we're going to find. So for example, what do we have known to us? What variables of the triangle do we know? Well, we know it's a 90 degrees, but we don't have this angle, so we can't use it to equal 180 and solve for that. But we do have 2 of the 3 sides. Now you could just use your Pythagorean theorem and work on that, but I would rather you guys, we're going to use trig. So like I said, we've got 2 sides. Now can anybody tell me, related to angle theta, what this side is? Yes, John. Yes, it is the opposite side because it's directly across from the angle, and this side is not touching the angle at all. Now can anybody tell me what this one is? Yeah, it's the hypotenuse. And just for giggles, what is this one? Yep, it's the adjacent. Well, we've got 2 of the 3. We have the opposite and the hypotenuse. So using our sine, cosine, and theta from SOHCAHTOA, you've got your formulas right here. If we have our opposite and hypotenuse, which one would we use? We would use sine because it is opposite divided by hypotenuse. So going off of this example, we would use sine, and we're going to keep the variable theta because we don't know it, equals, now what is the opposite? 2 divided by the hypotenuse, 3. Awesome. So now you may be wondering, now how do we isolate theta to solve for it? Now we're just doing simple algebra. Well, it's not as simple as it may seem because you can't divide something by, like we don't even know what a sine is. So to solve for sine, theoretically we would just divide by sine on both sides to isolate theta. However, we can't do that based on the functions that our calculator gives us. But as we do know, sine by itself would be sine to the first power. Well, divided by sine would be 1 over sine. Now, as we know, if it's on the denominator, if a variable is on the denominator of a reciprocal, it has a power of -1. Our calculator does have that button if you've ever seen it. So I'd like for you guys to get out your calculator, and I'm going to show you something that you may not have known about it. Our calculator has a function on it, and it is your second function. You hit the top button here, and it is sine. As you can see in the blueprint above the button, it says sine to the -1 power. So to do that, when we do that, we would be isolating sine. We would be isolating theta. So to do that, it would be sine to the -1, because we said we're divided by sine, of 2/3. Well, as you guys know, you can hit sine -1 now, and then type in 2/3, 2 divided by 3. And what does that give you guys? That gives you guys 41.8. So theta, the angle theta, is equal to 41.8 degrees. Now, using this, we could solve for any of it like we've been doing. But I'm just going to keep giving you guys examples over SOHCAHTOA, basic trig. So let's make our angle that we want to find this one. We'll make that theta. Now, does anybody want to give me a random number for any side? Okay. Billy, what do you need? Okay. We'll make the opposite side 45 units. Big number. Does anybody want to give us another side? Yes, sir. Okay. You want to give the adjacent 23 units. Big numbers. We're working with bigger numbers now. Okay, so now you just said that we gave opposite and adjacent. Now, can anybody tell me which trig function we would use for that? Yes, we'll use tangent because it is opposite over adjacent. So, we'll reuse our formula. Tangent of theta equals our opposite 45 units divided by our adjacent 23 units. So again, there's another button on your calculator that would be second function, and it would be the tangent button. So tangent -1 of 45 divided by 23. What does that give you guys when you plug it into your calculator? 62.9 degrees. Equals theta. And again, now that we have two of the 3 angles, given that this one's in the right triangle, it's 90 degrees, we can find any of it. We can use our Pythagorean theorem. But this just gives you, if you've only got one angle, which is our right angle, or 90-degree angle, we can use the given sides to find any angle. Now, I'm afraid that's all the time that we have today. I'm looking forward to seeing you guys at the pep rally and at the game tonight. Go team. With that being said, you guys are welcome to make your way down to the gym for our pep rally. So go forth, be good humans. Spread the love, spread the positivity, and have a great weekend. We'll catch back up on this on Monday. Thank you.